Hey guys, welcome to my channel. In this video, I will be starting calculus, just to build a foundation of some things that you will find in it. I will be onto the concept of differentiation, which is one whole important section of calculus. And we will do some basics of differentiation, i.e. differentiating simple indices. It is extremely easy, and don't mind those big words, they just boil down to a very simple concept at the end of the day, and you realize that there is nothing to worry about. Now, if you're new to the channel, please do like and subscribe for more math and other subjects videos. So to begin with, when you differentiate any value, say I've got this over here, if you want to differentiate this, whatever answer you get, it's called the differential. Yeah, so whenever you differentiate something, it is called the differential. And what exactly is a differential? So, a differential is just a more complex way of saying the gradient. Now, I'm pretty sure we must have heard of gradient at some point, the m in the y equals to mx plus c, or finding your change in y over change in x, finding the gradient of a line, so y2 minus y1 over x2 minus x1, So that it's just that simple thing. It is the same thing. It's not something that you haven't done before, but this is just being done in a different way. So now that we know what a differential really is and why we differentiate, let's look at how we can do it. So here's on the next screen. As you can see, this is the rule of differentiation. So now that we know that differentiating is the same as finding the gradient of a line, what you see below, this rule, is what we're going to use to actually differentiate. It is what the concept of differentiation actually revolves around. Now, it says n x to the power n minus 1. Now, especially if you're new, this is going to sound a bit, complicated, but it really is not. And nobody's going to ask you to write down this rule. What they're actually going to ask you, they're going to give you problems like these and, tell you to solve them. All they want to know is how you can use this rule. That's just what matters. But it is good if you still know it, just in case. So I have broken down this rule into these two simple steps that you have to follow in order to differentiate any indices. They're really easy to follow. There's absolutely nothing complicated about them. I will be solving these questions that you can see over here with these two rules, and you're going to see how they work, and I'm pretty sure you'll understand them. They are extremely simple. So let's just look at these. Now, our first question says y equals to x to the power 5. Let's look at these rules. I said what we'll be using to solve these. The first step says multiply x by power. So the power here is 5. Okay, for example, the power here is 8. So I'm pretty sure we know about power since, indices should be pretty cool right now. So this is the power and the x. So this is the x in the equation. Now, it's not always x. It can be t, it can be v, it could be anything. So don't, freak out if you see another letter. It is just the same thing. There's always an unknown value like an x or a v or a d or anything at all. So you multiply the x by the power. Yeah? So let's do that. So our x times the power, which is 5, which is obviously 5x. Yeah? So we are done with this step. The second step says subtract 1 from the power. Now, we had a power at the beginning in the question, so we can't just let it disappear like that. So what do we do with it? We subtract 1 from that power, and that's what this rule says here. So these steps are basically just a simple way of writing down this rule, yeah? So we subtract 1 from the power, which is 5 minus 1, so that becomes 4, yeah? So we just put a 4 as the power, and this is our answer, 5x to the power 4. And what do we call this? We call this a dy dx. We can see it in the rule here. So a differential is denoted by a dy dx. That is like a kind of sign for it. So let me just put it here. So dy dx equals to 5x to the power 4. This is just how easy it is. It's just these two simple rules that you're following. So you multiply the x by power, subtract 1 from power. So we multiplied 5 times the x, 5 is the power, and we subtracted 1 from the 5 to get the 4, and we put that as our new power. That is it. This is our answer. So let's move on to the next question. Let's come back here, and it says x to the power 8. We're still going to be using the same rules. These rules apply to all questions with indices. So we multiply the x by the power. So 8 times x. So our 8 is the power. So we multiply it, which gives us 8x very obviously. Next step, subtract 1 from the power. So our power is 8, so we subtract 1, which is 7. So 7 becomes our new power. And this is it. This is our answer. That's just how simple it is. You multiply and then you subtract. Yeah? And this time, we are gonna call this f inverse of x, not dy dx, because the question has an fx. Now again, please do not freak out if your question tells you to find f inverse of x instead of dy dx. It is the same as dy dx, it's just another way of saying it. So wherever the question says fx, you do an f inverse of x. Wherever the question has a y, you do dy dx, yeah? So there's that, and this is our answer. That's just how simple it is. I've got a few more questions down there, which are all unique. Let's move down. Just 3 more, but they're all unique, so they've got something different in them. So I just want to give you a kind of range of questions that you could see in the basics. So let's come back here. Now this says y equals to 7x to the power 3. Now obviously, since there's a y, we know that we're using dy dx first of all. So dy dx, what is it? Now let's use the same rules. We're using the same rules, yeah? So multiply x by the power. Now what is unique in this is that the x already has a number in front of it. So what are you going to do with that? So let's just go by the rules first. Multiply x by the power. So the power is 3. So 3 times x, as we did it up here in these two questions. So I multiply x by 3, which gives us 3x. But hey, again, let's not forget that there is a number in front of the x. What are we doing with it? We multiply it here again, because it is still multiplied with the x, right? We have a 7 times x. 7x is the same as 7 times x. All we're doing is we're adding a 3 to it. So a 3 is just an addition. So this was already there, and following this rule, we brought in the 3. So this is the addition. So 7 times x times 3. So which is going to give us 21x. Yeah? So in this way, you can just look at it like what you're basically doing is you're not multiplying the x per se with the power. You're multiplying whatever is in front of the x. So in this case, there was a 1 in front of the x. Here too, there was a 1. So you basically multiplied the 8 times the 1. Yeah, that's why you got an 8x. Here also you multiplied the 5 with the 1, so you got a 5x, yeah? So you're basically multiplying it whatever is in front of the x. So the 3 times what is in front of the x is a 7. So 3 times 7, 21. And we have the x. Again, the 3 doesn't just disappear. So we go to our second rule, subtract 1 from the power. So let's come here. Our power was 3. And we're gonna subtract 1, so which is 2. So this is our answer, 21x squared. Yeah? This is just how simple it is. There's nothing complicated about it. Let's go to our fourth question. So what's unique about this? This has a negative power. Now let's not forget that powers can be positive, they can be negative. We should know how to deal with all of them. And it's not anything different. We're going to use the same 2 rules. So the first rule says we multiply the x by the power, or whatever is in front of the x by the power. Yeah? In a better way to say it, whatever is in front of the x is what we multiply with the power. So first of all, our dy dx, let's not forget to put it here. Now we multiply what is in front of the x with the power. Yeah? So 8 times minus 4, which would give us minus 32. Let's not forget to put the minus because there is a minus. So minus 32x. Our next step was that we should subtract 1 from the power. So let's come here and subtract. So our power this time is minus 4. Minus 4 minus 1. So guys, it is a minus 4, so it wouldn't become a minus 3 since it's a negative. Minus 4 minus 1 is minus 5. So our power will become minus 5. Yeah? So this is our answer. Minus 32x to the power minus 5. This is just simply how you deal with negative powers. Now the final question that I have here, 9x. So I did not put a y. Just put it here. So we've got y equals to 9x. Yeah? Okay, let's do this. So y, to differentiate it, you'll get a dy dx is equal to, now 9x is the same as 9x to the power 1. Yeah? So what we do is the same thing. We multiply the power, this one. So when there isn't a power, you put your power. If you know there's an x there, there's obviously a 1 as the power. So you multiply the power with the x, or whatever is in front of the x. So 9 times 1 would give you 9. Yeah? And then we subtract 1 from the power. So 1 minus 1. 1 minus 1 is 0. So that would be the same as x to the power 0. And if you know indices, you should know that x to the power 0 or anything to the power 0 is the same as 1. So this x will become 1. So it's the same as 9 times 1. Yeah, the whole x becomes 1 because the x goes to a power of 0. So it's the same as 9 times 1. So differentiating 9x becomes just 9. 9 is the answer. So you could have different ways. You could have different numbers, different powers. You know, there are a lot of different ways of giving the question, but basically you're using this same rule to differentiate every single thing. You multiply x or whatever is in front of the x. I think whatever is in front of the x is a better way of saying it so that you don't get confused. So if there's nothing in front of the x, just put your own little 1 and multiply it by the power. So 5 times 1, you multiply by the power and put it here, and then subtract 1 from the power and make it your new power. That's just how simple it is and how easy it is. And these are the 2 rules you use. And on paper, obviously, this is the rule of differentiation that you're supposed to know. Or not. You could just use these 2 steps unless someone actually asks you to write down the rule. So it's just good to know the rule. But anyway, this was differentiating and the basics of differentiating. So differentiating indices. And I will be giving out further videos on differentiating and calculus. So if you would like me to release a special video or anything or any topic or any past paper you want me to solve, please do comment down below and tell me what you want me to do for you, what video you would like, and I would work on it. Thank you so much for watching. Please do like, subscribe, and comment on the video.